I am Anish Pathasadi of class 10D. Ek Bharat, Shrestha Bharat. As a part of this program, I will be discussing the physics behind sunrise and sunset, explained through Dal Lake, Srinagar, Jammu and Kashmir. Also showing some pictures of Dal Lake and Kanyakumari. Sunrise and the sunset. Everyone at one time or another has marveled at the beautiful red and orange colors of a sunrise or sunset. Although colorful sunrises and sunsets can be seen anywhere, certain parts of the world are especially famous for their twilight hues. The deserts and tropics quickly come to mind. Eye-catching sunrises and sunsets also seem to favor certain times of the year. You can see the pictures of sunrise to the right of your screen. Let us discuss sunrise and then discuss the physics behind it. Why is sunrise and sunset red? Color of the sun at sunrise and sunset. Have you seen the sky and the sun at sunset or sunrise? Have you wondered as to why the sun and the surrounding sky appear red? Let us look at the video of sunrise in Dal Lake, Srinagar as an example and find out. The scattering of light helps you to understand the bluish color of the sky and the reddish appearance of the sun at the sunrise or the sunset. Light from the sun near the horizon passes through thicker layers of air and larger distance in the Earth's atmosphere before reaching our eyes. However, light from the sun overhead would travel relatively shorter distance. At noon, the sun appears white as only a little of the blue and violet colors are scattered. Near the horizon, most of the blue light and a shorter wavelengths are scattered away by the particles. Therefore, the light that reaches our eyes is of longer wavelengths. This gives rise to the reddish appearance of the sun. Next, we will see what is advanced sunrise and delayed sunset and also atmospheric refraction. Advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before sunrise and about 2 minutes after sunset due to atmospheric refraction. The apparent flattening of the sun's disk at sunrise and at sunset is also due to atmospheric refraction. Atmospheric refraction. During sunrise, the light rays bend due to our atmosphere and we see the sun early even though the sun is just below the horizon. Similarly, at sunset, due to the same bending of light rays, we see the apparent position of the sun, not the actual position. To sum up, due to refraction, we see the sun rise about 2 minutes before it's actually there, and during sunset, we see it for around 2 minutes more, even though it has already moved from that position. I would like to explain the atmospheric refraction a bit more in detail with the picture on your right. Advanced sunrise and delayed sunset due to atmospheric refraction. Do you know, due to atmospheric refraction, sun appears to rise early by 2 minutes and set late by 2 minutes, which is called advanced sunrise and delayed sunset. While when the rays from the sun hit the atmosphere, they get refracted. Due to this, the sun appears to be at an apparent position, which suggests that it has already risen. The same happens in the sunsets. After seeing the sun still appears in the sky due to the same refraction phenomenon. Before looking at the aspects of sunset, let us see what is visible light to understand the sunrise and sunset concept better. What is visible light? Sunlight is a white light that carries all the colors of the rainbow: red, orange, yellow, green, blue, indigo and violet, which is easily seen when shown through a prism as it bends the light into its constituent parts. White light actually consists of more than what we see with the naked eye because it uses ultraviolet and infrared rays too, but almost no humans can see those. Visible light. The visible light spectrum is a smaller chunk of a much wider electromagnetic spectrum output by the sun, which also includes ultraviolet light at higher frequencies and infrared light at lower frequencies. The visible light spectrum is categorized in order of wavelength, that is, the literal length of the wave of light. Because visible light waves are so short, they are measured in nanometers, which is a thousandth of a meter. Red light has a wavelength of around 700 to 635 nanometer. whereas blue light is shorter at around 490 to 450 nanometer. Now, let us look at the pictures of the sunset towards our right and discuss more about the sunrise and sunset. Light that looks white to our eyes actually is made up of many different colors. Each color can be thought of as a light wave with a different wavelength or size. Within the small range of wavelengths or colors that we can see with our eyes, the shorter waves are blue and the longer ones are red. Colors such as green, yellow and orange lie in between the blue and red ends of the visible spectrum. Rayleigh scattering. Before watching the video of the sunset of Dal Lake, Srinagar, let us find out about Rayleigh scattering. Rayleigh scattering is the phenomena of scattering of light particles majorly when the molecules of gas, sometimes also be solid and liquid. This scattering of light was first noticed by Lord Rayleigh in 1871 and thus named so. Basically, when electromagnetic light propagates through air, then the back and forth movement of electrons inside the molecules of medium, air, generates an oscillating electric field inside it. So, when photons are allowed to transmit through these molecules, then some photons get absorbed but then retransmitted in multiple directions by the air molecules. This is known as Rayleigh scattering. The appearance of the sky in blue color is due to the scattering of sunlight by the atmosphere. Rayleigh scattering law. Rayleigh scattering law states that the amount of scattering of light is inversely proportional to the fourth part of the wavelength. It is given by I equal to 1 by lambda to the power of 4. The strength of scattering depends on the wavelength of light and the particle size responsible for scattering, but this interaction somewhat changes the polarization of incident light. Due to this, some of the light energy gets absorbed by the molecules of the atmosphere. This energy is then re-radiated in different directions that leads to cross scattering of light, more specifically termed as Rayleigh scattering. We know that the wavelength of blue color is less than the red color. Thus, due to the shorter wavelength, blue light scatters comparatively more than red light. That is the reason why the sky appears blue instead of any other color. What you are seeing on your right is the video of sunset in Dal Lake, Srinagar. You can see the reddish tints in the sky. The explanation for the reddish tints seen in the sky at either end of the day lies in Rayleigh scattering. As it passes through layers in the atmosphere, shorter wavelength light is scattered more than longer wavelength light. Sunlight is made up of all the colors of the visible light spectrum: red, orange, yellow, green, blue, purple, which may seem familiar as all the colors of the rainbow. Rainbows appear when the different wavelengths get broken up through refraction and scattering in the atmosphere. Basically, as the light passes through different densities in the air, the light bends, kind of like it does in the prism, and bounces off tiny particles that are in the air. This also explains why, during the day, the sky is blue. The particles that are in the atmosphere scatter sunlight so that the blue wavelengths are not absorbed but reflected. At sunset, the same things happen, but because of the angle of the sun and the volume of gas and therefore the density of gas that the light passes through changes, the sky takes on a reddish glow from the longer wavelengths in the visible light spectrum. This explains the reddening of the sun during the sunrise or sunset. Now, let us see a couple of questions. In simple terms, what makes a good sunset happen? It depends on how you define good, but let us assume it is a strikingly colorful one where the colors are spectrally pure, say vivid orange or red, as opposed to a more muted palette. Keep in mind that what we see with our human eyes is just a tiny part of the electromagnetic radiation that is given off by the sun. That radiation contains a wide spectrum of wavelengths, but your eyes are only sensitive to certain parts of it, the so-called visible wavelengths. Different colors are associated with different wavelengths. And depending on what happened to the light before it got to you, some of those visible wavelengths don't even reach your eye. Portions of it are absorbed and filtered out in the atmosphere. So really there's a good sunset every night. We just can't always see it from the ground. You may have noticed this if you've ever taken off in an airplane at sunset. It might not look like anything special from the ground, just a whitish pink sky, because you're still within the atmosphere's boundary layer. That's where all the large particles are trapped, things like dust and pollution. But as the plane gets above the boundary layer into cleaner air, suddenly the sunset looks very vivid. It's all a matter of perspective. Why do we see more orange and red colors in the sky during sunrise and sunset than we do at other times of day? When a beam of sunlight strikes a molecule in the atmosphere, what's called scattering occurs, sending some of the light's wavelengths off in different directions. This happens millions of times before that beam gets to your eyeball at sunset. The two main molecules in air, oxygen and nitrogen, are very small compared to the wavelengths of the incoming sunlight, about 1,000 times smaller. That means they preferentially scatter the shortest wavelengths, which are the blues and purples. Basically, that's why the daytime sky is blue. The daytime sky would actually look purple to humans were it not for the fact that the sensitivity of our eyes peaks in the middle, green part of the spectrum. That is closer to blue than to purple. But at sunset, the light takes a much longer path through the atmosphere to your eye than it did at noon, when the sun was right overhead, and that is enough to make a big difference as far as our human eyes are concerned. It means that much of the blue has scattered out long before the light reaches us. Hope you enjoyed my presentation. Thank you.